Okay, so um, where should we start? What do you guys want to know first on the lay of the land? I guess the lay of the land, right?
Yeah, I think you said there were some changes to the original like art proposal of the architecture. So like maybe
Yeah, I can
go
kind
over
of walk
that.
you guys through the architecture. Um, that might be the best to bring you guys up to speed on the architecture as much as possible, and kind of walk you guys through everything I know. It's gonna be it might be a longer call, like an hour or so.
It's fine. Yeah.
Then we can break it through, break down uh, what parts each of us are going to pick up. So, okay, so let me just share then, so you guys can see. Um, I've
And
got
then
the,
something I think all of us might want to know too is just like, what falls under 18.5, 18.6, and just
we need to scope that out, yes.
okay, cool. Yeah,
Um,
perfect.
and I don't know, like that timeline is going to be TBD to all of the current work that we have to do on the server side, right?
Hmm.
For code indexing only with the
Yep,
current architecture, and also the SDLC aspects might influence it. Um,
that makes sense. Yeah.
and I'll walk you guys through that so we can so you can know basically. So first let's walk through the server side, um, graph server side. Let me walk you guys through this. Well, let me turn on my fan. It's very hot in here. So, okay, so how familiar are you guys with this?
I just gave this a read a few hours ago, so I'm decently familiar. Maybe not with as many of the permission aspects of it, just because I don't know that part of the stack that well, but the
All right.
general I flow I know also well. So,
Uh,
all
I
right.
also
Gave it a read, so maybe focus on like the important stuff and maybe what changed because from the proposal it says like we're going to use Kuzu and do all these things, but I feel like the latest discussions point towards using Neo4j or some other like
That's different.
server
That's
side DB.
Yeah, that's different. Not yet. Hold on, we'll get there. That's way
All
ahead.
right. All right.
Um, okay, let me do this then. I'll just act like you guys haven't seen it, and then you guys can let me know if I'm repeating myself.
Okay. Right.
Um, all right. So the current server side, let me break this down. Um, what's a good way of breaking this down? Let me think. Um, all right. So we've got, there's really three, no, two phases. All right. No, actually, there's three. All right. Three phases here. I should have just copied this. Hang on. All right. So we have three phases here. We have the local one that we just built, right?
Mm-hmm.
Then there's the code indexing graph. And then there is, sorry, server side code indexing graph. Then the other problem is tying that SDLC data to code graph, right? Those are the three
Mm-hmm.
categories of problems. Now, this one is quote unquote complete. So we'll mark this as green. In the coming milestones, a lot of the plumbing that we do in the server side code indexing graph does translate to the SDLC graph. Even if we architect a different data source and ingestion pipeline of the tasks. And you'll see that in a second. So the way that the server side, the current, what you see in this document here, the way that it works is as follows. We have Rails, right? We have this regular Rail, we have the GitLab monolith Rails instance. The Rails application has the following tables. And again, this is leveraging what's called the Zoic architecture. So everything that powers Zoic, we are modeling the code indexing after. So what do I mean by that? The Rails side has a few tables. The main things that you guys need to think about, start learning and thinking about is replicas, the replica instances, the difference between a node and a replica, and the task table. So you can see in this graph here, basically, the architecture, what Dimitri and team built for Zoic is this is a state machine inside of Rails. That's the way you can think about it. So basically what happens is Rails posts these tasks based on events that happen inside the application. In this case, it's anytime you push to a branch, anytime you merge a branch into main, anytime main gets updated, we save a task into this task table, essentially. And before this, when knowledge graph starts up and when the Rails instance starts up, it registers all of this logic registers these concepts of nodes and replicas. So you can have many nodes, and some of those nodes share replicas. So the whole point is to enable horizontal scaling in the Kubernetes cluster. Have I lost you guys so far or no?
No, that makes sense.
Nope. So the way that you can think about this is basically you can have two nodes, right? And those nodes can be a replica 1 with the namespace 1, right? Namespace, think of it as like GitLab org, right? If you go to gitlab.com, GitLab org, this is a this is a top, what's called the top level namespace. I don't know if you guys are aware of this. You're gonna have to get very familiar very fast with how the data model in GitLab works. So just be prepared for that if you guys want to move through this quickly. So this is called a top level namespace. Let me link namespaces to you guys as well. This is a good document written by Dimitri. Let me link it to you in the chat. So we have this thing called namespaces. So GitLab org, the top level group, is called the top level namespace. And in the database, I didn't know this, but the way that the data is modeled is every namespace member can be either a namespace, like a top level namespace, like GitLab org. It can be a group, which can be a group or subgroup or nested group. It can be a project, like GitLab org, GitLab, right? This is a namespace ID. And it can be a user namespace. So it can be GitLab org Michelangelo.io, like my username. This is also a namespace. And you guys, if you can't tell, the reason why, it didn't click to me until I realized it, but Michelangelo.io is actually a namespace because if you go to personal projects and you go to users, Michelangelo projects, this is a namespace, just like groups.
Yep.
Right? So when you create a fork, it gets forked to that namespace. Does that make sense?
Yep. It's a recurrence relation. Yeah.
So this is some of the data modeling of how GitLab works. So give this a read. Do you guys have the link saved? Can you also put it in the Slack chat?
Yeah.
Okay. So that tangent is important because that informs how the horizontal scaling and the data separation layer works right now. Now, this may change with the SDLC data when we index it, and when we collaborate with data engineering. So how this works is basically you can have multiple nodes in the Kubernetes cluster, and each of these nodes can be labeled as a replica, and they get assigned a namespace ID, a top-level namespace, I believe. I have to double check on the specifics of that because it might be like multiple namespaces get assigned to a single node. That might be covered in here, but that's like an implementation detail. The key thing to know is just thinking at GitLab org. When the service starts up and a new namespace is created, blah, 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 it gets assigned a particular node in the cluster. And that does it through through the knowledge graph replicas table. It was a little bit fuzzy to me how it gets the replicas, or how it creates the replicas. Adding a new graph node. Okay, GitLab maintains rebalancing repository DBs by updating the list of replicas in primary node for each repository in GitLab Rails DB. Yes. So for
Okay.
sorry?
No, I just said okay. Yeah, yeah.
Yeah. So yeah, so here it is. For repositories, we should use the new node as a primary node. Steps for each repository be GitLab adds a new graph node to the list of replicas where the repository should be synced. When the replication is finished, it sets the new node as primary node for the repository. Yeah. So that's basically it. You need to know that right now the Rails application is managing which nodes there are.
Okay.
And let me spin up my local GDK so you guys can actually see this. Let me do.
So like just so I understand, there will be like a node and maybe replicas for each namespace. So whether that's like the GitLab org namespace or that's like your user namespace, there will be a node for each of these.
I think it's only for top level namespaces in this case. The namespace
Right.
logic
But
is going to be different later on.
but
Yes.
let's say there is like 10,000 businesses or 100,000 namespaces, so it would be 100,000 nodes.
I don't
Or are
think.
you planning some reuse based on
Yes, I
like
think
some
it's
okay,
like it looks at like the storage requirements and then assigns a new node
yeah.
when it runs out.
All right, dude. I got scared for like a second. I was like,
No, no,
I was like, dude, what is this?
no, no.
Yeah, it makes sense.
So I did, and that's what I was talking about here when it runs out of storage and whatnot.
Yeah.
Though we can rethink this if we think about using something like Neo4j, but that's again, we'll get there when
Yeah, of course.
right. And even if we go through with all of this here and we push out all of this, it won't be a complete re-architecture. It would be somewhat of a re-architecture, but yeah, I don't know. We might want to think about that before.
Well, we may want to think about it like right now when we write the code, right? So like let's not write everything like let's not tie everything too closely to the DB in case like stuff like that change.
Yes,
Because then we'll rewrite because then if we tie the code with a DB and we change the DB, then we have to rewrite everything. So let's like keep maybe like some layer of abstraction just so we're safe. Like,
yeah. Um, we'll get there though. Okay, so we got this knowledge graph task table. We got the Zoic nodes. Blah blah blah. You guys understand that part. So now you're probably wondering, how does the knowledge graph service know when I push to my branch? How does it know when to start an indexing task, right? That's probably your next question, right? What happens is knowledge graph. We'll just talk about knowledge graph as a service. I'll talk about the Zoic and Golang related stuff in a second. But essentially what happens is knowledge graph will send a heartbeat every few seconds. And that's what I wanted to show you guys. So give me a second. Let me pull it up.
right. So Zoic will act as kind of a proxy, right?
Yes, the Zoic orchestrator. But I just want to open up a workspace. Hold on. Open a workspace from file. I just want to, if I show you guys like the thing working on my machine, you'll be like, oh, okay, I get it. I get it. It takes 2 seconds to spin up. Okay. Wait, hold on. Hold on. Okay. Hold on. Okay. Can you guys see my screen?
Yeah.
All right. So let's go down here. And all right, so you see knowledge graph, you see knowledge graph, GitLab code parser, GitLab, GitList, GitLab task. Okay, so let's go to first GDK. Let me stop it in case it's running. I think it's all down. Okay. Let me do GDK start. And this is going to start up Rails and Postgres. Now let's go to, where's Zoic? I thought I added that. Okay. Well, either way, we'll just go here in the terminal manually. Actually, let me just do it on here because it'll be easier to show you here. All right. Let me zoom in. Let me go to Zoic. Okay, so we got the Zoic indexer. And I do make export GDK directory. So this is my GDK directory. Let me do GDK stop this. So it'll stop the existing ones and then GDK, or sorry, make GDK. So this is going to start my local POC version of the Zoic stuff. And so just watch the logs here. What's going to happen in a second is it'll start doing the heartbeat. All right, so you see the status here. So this is when it does the heartbeats. Last thing, let me set up here is let me go to knowledge graph. Let me go to GKG. You'll see maybe it's SDLC. Switch SDLC. No, that's not it. POC, yeah. I have too many freaking branches. Okay, so we do cargo run, HTTP server deployed. So we have another thing, as I'm sure you guys saw, we're creating another HTTP crate for the deployed version of the server, right? Sorry, I just need to get it Rust log info on there. Great. All right, so now let me show you my GDK should be up and running. All right. So, man, you guys actually have not been involved in this, and we need to get you up to speed ASAP. And if you haven't set up GDK, I recommend setting that up also ASAP. It's a little bit involved, so it'll take like a day to learn. All right. So we have your work projects. We got orders, service, streaming service, blah, blah, blah here, right? Now I vibe coded this panel called the knowledge graph admin panel. I do think we should have something like this in the future, like an official version of this. My vision for this is basically we make everything turnkey so you can have observability into everything that's happening with your knowledge graph. But you can see these are the enabled namespaces right here. I'm just querying the task table. These are the replicas, right? And it should, yeah, so here's the reserved amount of bytes. And then these are the different nodes of which they exist, right? So yeah, and then we have two nodes here. So this is one node and two node. And so if I go ahead and kick off an index, I do GitLab org, for instance, and I do trigger indexing. and we go back to here, first you're going to see it's going to pick up the task. Did it already do it? Okay, yep. So picked up the task, and then it forwarded those tasks over to the knowledge graph server, which picked up those tasks. And what's happening here is it grabs the task, it gets the Gitly information, it makes a call to Gitly with the Gitly information object. And I can show you guys the code if you want, but it basically passes the connection info from the proxy to the knowledge graph server, and we fetch from Gitly. And then the exact same thing that we run locally, that happens on the server, right? And then it just puts it in a where we decided to store the repos in this format, right? So it's numerical and it's by like the thousands in so we like separate the directories, if that makes sense, for like the different file nodes.
And what does each subdirectory there mean? Like starting from the first zeros to the last one?
Forget the logic, but let me go to HTTP server deployed.
I'm assuming that'll change, so it's not that big of a detail. I'm just curious. But
May change, yes. Let me just do, I think it's index mod. Deployed indexing executor. Wait, this isn't it. Somewhere in there. I remember Jan and team explained it to me.
I can take a look async, especially if it's going to change. I was just curious about the.
It might be the same for us getting it through the door, but I don't know. Again, like it might also change. But it's just if we're gonna change things and we need to do it fast, because we can't like spend a month re-architecting, right?
Agreed.
Where is the, hold on, tasks, dependency, symbols, references. I literally wrote the code in here. I forgot what code I wrote. Fetch index in index full. Here it is, maybe. Nested repo. Okay. Nested path.
Okay.
Yeah, so format to at least 9 is with leading zeros. Yeah.
Okay.
So it's just a way of storing the databases for a directory or something.
I see. So it's like essentially a hash.
Yeah, I forget the reason. Okay, so makes sense so far.
Yeah.
Yep.
I lost you guys. Bogdan, you've been quiet.
I'm here. Are these in terms of like data retention, which node is responsible for like I guess the question I have is do all the nodes have a shared remote volume, or do they each have their own volumes where they store the repositories and the replicas that they're assigned to? Because you can
Like a
have
PDT?
yeah, exactly, because you can have multiple nodes be responsible for the same
Pretty sure the
the
PVC is shared across nodes.
okay.
Well, let me look it up.
So that could be a reason for why the files are stored in like a hierarchical format. I see, yeah. Okay, so
Sure.
they all do share the same persistent volume. Gotcha.
Yeah,
Okay.
pretty sure they have the same PVC. All right. So now you guys are hopefully understanding the world the double life I've been living while you guys are building the local stuff. This is all the stuff that you guys are gonna have to learn really quick. But you'll learn it fine.
Is the architecture you're showing like kind of final? So like is the, let's say, a node per X amount of project something that's going to stay, or are we planning any changes?
We'll get there. We'll get there. It might, I don't know, like I don't want to, I think we should keep it for now. But it may change in the event that we do SDLC indexing and indexing those things together, especially if we choose maybe a different database, but there's cons and pros to that, right? But we'll get there. I'll lead you into because I want people who are watching this also to understand like there's like a story here, right? That pieces all these different things together, right? So like
Yeah.
just treat this as final for now until we get to the later half of this TED Talk.
Yeah, that works. I was just thinking in terms of like maybe working on observability and like I'm just trying to figure out like if we think this is like permanent, then but yeah, thanks. That answers it.
Yeah, I mean either way, the observability work that you're doing just it will apply either way, right? For the
Yeah, but the extent
telemetry,
it was just
not
to
to the
gauge like
extent
the
of
extent.
yeah, if you add like node replica metrics and all that stuff, that might be
Yeah, it's like let's say do we do Rails changes to have an admin panel or not? So if it's not like final approve, we're going to do this, like avoid Rails until like as much as possible until
yeah,
because
no,
making
the
changes there.
observability, like I don't think we need I don't think we should focus too much on Rails for observability as much as
Agreed.
the service itself needs observability. Like we need open telemetry and those metrics to
Yeah.
be defined in the service. And we should be able to see them in Prometheus and Grafana and all that stuff.
Yeah.
But we'll get there in a second. I'm just walking you guys through the architecture. So I showed you guys the proxy, right? So this is the proxy here. The reason why we have this, we're using the Zoic proxy is because it allows us to leverage all the polling logic, all the task fetching logic, JWT exchange from the Zoic service um, to Rails, even though I think Dimitri's also adding JWT into Knowledge Graph itself. Eventually, we might even think about we talked about it like we might not even need the Zoic orchestrator if later on the down the road. But for now, we're leveraging we're leveraging it because we want to leverage what we can that exists so far. So remember that whole FFI discussion, right?
Mm-hmm.
So the whole thing that was happening essentially is we were putting the entire indexer into a Go binary here, into the Zoic orchestrator. And now hopefully you guys can see that's a little bit of a problem, right? Because we have a full-blown stateful service that also has like a bunch of special querying logic that we were going basically fitting into the Go binary. So that whole FFI and the design document change is the context for that whole discussion. And like you guys probably already know this, we decided Rust will get its own dedicated process.
Yes.
So far,
Yeah.
you guys are already familiar, Bogdan?
Mm-hmm.
Yeah.
Yes, I commented in that one issue.
Okay.
Yep. I think
Yes,
all
we
of us
should
did.
we should go
We're just
with
rehashing,
service.
just so you guys can understand. But does this picture make a little bit more sense now? Like the whole 10,000-foot view?
Yeah. It might be a dumb question, but how do you prevent nodes from picking up separate nodes from picking up duplicate tasks? Is there some I'm assuming, Postgres is the source of truth. Do we update?
It calls back. So
Okay, it calls back. Okay.
so that's how you guarantee like the exactly once essentially is it creates the task, the indexing task. I think there's maybe some Rails logic like you push a branch and then you push it again, and the first one has an index. Maybe it like cancels out that task or something. You'd have to
Gotcha.
do that. Um,
So when I'm developing it, I should just assume that whatever task I'm indexing, I should just make the assumption that like I have I essentially have a lock on this task
It
and no
should.
other node is executing. Okay.
Yeah, because it
Okay.
goes through and then the I think the heartbeat also marks it as processing, right? So
Okay, I
you
see.
can see like if I trigger indexing, it goes from pending, right?
Yeah,
And then Zoic probably marks it as processing. And then when the indexing is complete, it's another callback from Zoic.
gotcha. Yeah, that's all I was wondering, whether we would have to do some of that or if Zoic does it for us. Okay, this makes sense.
We
I
can
can show
table
you guys
this
the code if you want.
We can maybe like have this discussion later, but I'm curious why I feel like it's better to design that like you could and like it's better to design by the fact that you could get multiple tasks. It's an async system. I feel like if we're creating these boundaries, it might be like error prone. Like that like the Node.js is an independent service that like just receives requests to do stuff, and then if we assume that there is a lock, I feel like that's a bit risky as this scales.
Uh,
I prefer like eventual
I know
consistency.
Zoic handles millions of them very, very well, but
Okay, all right.
Yeah,
Maybe
I would
just like
imagine I would imagine because the data structures that we're using are the same as Zoic, like fundamentally these are operations on namespaces. Like I will, I'll happily trust their implementation, and if we need to change something, I'm sure we could talk to them about it. But
and
yeah,
it might change. I think the code indexing, code indexing task model might be the same, because there's no event stream for. We'll get there in a second,
yeah,
but that's a good question. Like I'm gonna post this video anyways, and Dimitri will uh he can watch it and then reply to that. Okay, so makes sense so far. The only thing that we haven't covered basically is that Rails, or sorry, that this knowledge graph service calls out to Gitaly, right?
hmm
It will call out to Gitaly. Right now, the Zoic client is calling Gitaly, so it gets the task, the indexing task, and then fetches the files and creates a temporary directory. There's part of my work that I'm going to pick up, Dimitri and I are going to pick up, is creating a Gitaly client. So I think we can create a new repository, like a new project, Rust project, and get the protos. I already created like a POC for that. So it's like in this code here, I created a new create Gitaly, and it's really simple. It just takes the protos, it uses a Rust dependency for proto, and establishes the connection, fetches the repository, and
great.
gets the file at a particular revision, blah, blah, blah. Like I coded all that. And what you guys just saw happening, that whole exchange, is literally it's fetching from Gitaly
Cool.
files. So
All we need to add is just some way to get diffs if that's possible.
yes, so you'll
Yeah.
so this part you'll need to get probably it might even be better that you and Omar take out, like I get the scaffolding there, but you and Omar take the responsibility of take the lead on getting diffs and building out that proto and all that stuff, right?
Okay. Yeah. I'll talk to them. Yeah.
That's what I was hoping, is like you and Omar can take the proto, like the reindex, all the stuff that's needed for reindexing. Like this will be in scope for it, essentially.
Yeah, that makes sense. Okay, great. Yeah.
And then we also need Gitaly because in the tools that we currently have for traversing the graph, we read the files, right, guys? So
Mm-hmm.
we also will need to think about fetching from Gitaly when at query time to read the files. And we'll need to think about maybe making a cache if it's the same file at a particular revision, so that you're not like spamming Gitaly, right? All that.
Yeah, yeah, that's I can see how that's a whole project for you and Dimitri now. Yeah.
Yeah, you see now?
Yep, I do. Yeah. Yeah. It's just something that we can't spam. So it
Yes.
necessitates, yeah. Some optimization. Okay, yeah. That makes perfect
Um,
sense.
so yeah, so that's part of that. So from there, that's pretty much the deployed knowledge graph. Honestly. The other part is the querying aspect. So let me explain how that works. Um, so I was explaining this to Mo, one of the security guys earlier. So what happens is basically Rails will call GKG for the list of tools, right? During the MCP tools list MCP tools call, right?
Hmm.
It'll ask, is the user authenticated? Does it have Duo? Blah, blah, blah. Gets back the MCP tools list in the Rails MCP server. Then from there, when it executes a tool, like one of our get definitions tool, it'll provide in the params the project full path for each. So you know how we have absolute project path? We
Mhm.
create a new tool with project full path or something, and the LLM will input like the GitLab org/GitLab, right? That's
Yep.
it. And it'll also input any of the other um, parameters that exist for our current tool set. And then what'll happen is Rails will parse this. I don't really necessarily like this, but it's the fact that we don't have an auth service is basically the reason why we can't do it. But it'll parse the JSON body, look for this project full path. So this will need to be a requirement for every single query for the code indexing,
Okay.
so that we can have some type of authorization, right? Um,
And the path being the absolute path for that database, for that a repository, a database that's inside of that global volume, right? The one
yes,
that you
yeah.
shared between
So
all the
like
nodes. Okay, yep,
So like
makes sense.
basically it'll be like this. So if the LLM makes a query to this project path, GitLab org GitLab, right?
Yep.
Or it makes a query to GitLab org, right?
Mm-hmm.
If you want to do a group level search. We might even stick to just project at first because doing group level might be more complicated. And also at that point, like we need to think about the SDLC stuff, right?
Yeah, I was gonna say that's tantamount to like those federated queries we were talking about earlier. In Neo4j, we probably don't want to be querying 10,000 Kuzu databases like individually, that
Under the
sort of stuff.
current model, right? If you do like
Yeah.
a level search, we're going to be querying 10,000 databases or
Yep.
whatever the user has access to. So, like that, those are things we need to think of.
Yep.
So if we go back to here, basically the model will work though. Just assuming we're only going with one project for now. What it'll do is it'll take that full path. It'll look up GitLab org, and then there's a project object in Rails. So if I go to, let's not go there, let's create a new one. GDK, Rails C. I think, I forgot what it is. Also, if you guys aren't familiar with Rails, you're gonna have to get very familiar with it as well. Uh, if I can remember the freaking commands though. Okay, project, here we go. So P, this is basically running the active record selection on getting the project. So GitLab org user service, right? Now we
Mhm.
set it to the P variable, and you see this ID. This is the
Yep.
So we'll have a similar query where it'll take that path that we just input, convert it to the project namespace ID, right? Project 4 or whatever, and it'll query those tables that we were talking about before. It'll query the replicas table and whatever node it lives on, right? The same thing that we were showing in this admin area. It'll do the lookup to find where does the data live, essentially. And then it'll run that. Well, maybe we don't want that. Maybe we'll delegate that to GKG service. I have to talk to Dimitri about that. That's a little fuzzy to me. But basically, we'll have that information and we'll query the appropriate node and get the data, essentially, and then return it. So that's how it is. And this, by default, will run the authorization on the user's project at this step. So when we convert the full path to the ID, we'll also do like is user authorized, right?
Perfect.
That path makes sense. That's the other piece. It's a lot, isn't it? A lot.
It's
No,
fun though. It's
it's
fun
not that
though.
bad.
It's fun. It's basic CRUD stuff. So I
Yeah,
mean,
it's just reading from tables and forwarding requests.
Yeah.
um,
I think this is exciting. We're getting into the heart of the beast. So
yeah. Yeah. So this is how this works. Yeah, that's pretty much pretty much it in the design that I can think of. Do you guys
Uh,
want to jump into the SDLC stuff and how
when
that
we
kind of throws a wrench into everything?
Yes, just a super quick tangent. To resolve our debate about querying the code graph at a lower level, do we want to actually properly parse Kuzu queries like in 18.5 and be able to do query rewriting, that sort of thing? And it's a bit of a lower low discussion, but I just wanted to bring it up so we can talk about it later in the conversation.
What do you mean, parse queries like LLM generated queries?
Both LLM generated queries, but also to solve that DX debate that we had where we were using numerical IDs and we wanted to actually translate a query from using as string based querying to numerical based querying.
Yeah, that's a good one. I don't know. It also depends on if you've changed your mind on whether we should use string-based IDs or not.
I mean, yeah, that's something that before we go into any complicated technical work about actually parsing, that's not going to be that difficult, but it'll just be a lot of boilerplate. There's a lot of room for mistakes. First thing I want to do, and we can do this during 18.5, it won't take long, is just to do a performance analysis of like, do string-based IDs, like is
I already did
Kuzu's.
that for you. You want to see?
Yeah,
I tagged you in it.
I think I got tagged in 50 million things, so I don't.
Yeah, no, it's fine.
I must have missed it.
Being facetious here. I'm sending you the link. So I
Okay.
did this as part of the SDLC testing. I created a full pipeline. I generated a 23 gigabyte size database,
Okay.
compressed with Parquet. Is it Parquet or Parquet? Parquet, right?
I just call it parquet, but I think some people call it parquet. It's like
Uh, yeah,
tomato. So
Parquet. So uncompressed, 91 gigabytes.
Mhm.
This is just modeling users, groups, projects, issues, MRs, epics,
Mhm.
SDLC data, essentially.
Yep,
I created 72 million nodes, 268 edges.
it's a
Um,
lot.
and these are not lightweight ones. Every description has, I think I put like 500 characters or something. You have to look in the code.
Mhm.
5% of the descriptions are 1 megabyte in size.
That's quite a bit. Yeah.
And these are the numbers I got, like counting all
Okay.
users, count projects, and then more aggregations. Like these are kind of slow, right? But again, this is on my MacBook. Um, and anytime I included a node that had a very, like anytime I included a query that included description, the query time went from like 50 milliseconds to like 200 milliseconds or something, right?
I
uh,
think that makes sense because Kuzu's buffers are only so big. It was probably like hitting disk a ton. Yeah, that makes
yes,
sense. Yeah.
yes. And so and the major thing to note here is this is not, I think the node IDs are not numeric. I
Okay.
um I've honestly forgot what I wrote.
Yeah, because here you're talking about long descriptions, but when we're talking about like UUID or ULIDs, it's not the same scale.
I guess the question is also for numeric ID or for non-numeric IDs for string-based
Oh,
for
I did do numeric IDs. ID 100.
or yeah, for columns that we were originally swapping string-based IDs to numeric IDs. Yeah, I guess do you have any like I guess do you have like a differential test where there's one with a numeric and one with string-based? Because
I thought I did that, but I didn't. I forgot I did numeric IDs for.
yeah, because that'll just again, I don't
We
mean to
could
throw a
just
wrench
run
in
the
it.
same thing probably here with and without.
Yeah, I can honestly take the lead on that because honestly I also just want to find out like
Yeah.
whether or not like the numeric based ID thing is even kind of worth it. Because if it's not, I'm happy to tear the code out. Like,
Because if it's the same performance or negligible hit, I much
Yeah.
prefer string because it's going to make everybody's life easier.
I
Right.
completely agree. It'll just be a million times more interpretable. Yeah.
Can we
that's-
just use UUID, which is just 2 ints, and we can randomize it.
That's the same thing as doing a numeric ID, though.
Yeah,
Practically
but it will
speaking.
not be sequential. It will be random. You just pick random UUID. There is like very low chance of collision.
No, at that point, Mike and I are saying just use like the issue ID, right? Like
Yeah.
GitLab, it would be like GitLab
Oh,
project path ID,
Ye-
numeric ID or something.
Yeah, Bogdan, the main influence behind me choosing or making the decision of doing the numeric ID was just because like I was like, okay, Kuzu's like column-based compression because they don't have segmentation. They just added it. It might not be that good for compressing like long kind of column subsets of strings, but they have pretty good integer compression. So I just decided, okay, like it's probably going to be a lot better.
yeah, but
in terms of database
UUID
size.
is not a string. It's just long int.
I agree, but if it's randomized, it's very hard to compress randomized data,
They
right?
don't.
Oh, yeah.
Does Kuzu support UID or no?
That's a great question. I don't actually know. It looks like they do. I don't know if they have a UUID type or if it's just a string equivalent.
Yep.
Yeah, probably they
Yeah, they
just
have
back it
a
up by
they have
strings.
a type. 16
Oh, they have a type.
bytes.
Oh,
That's
oh,
big.
they have UUID.
That's a lot of bytes.
Yeah, it's two long ints.
It's too
Basically.
long ends. Okay.
Yeah.
Okay.
It should be long enough because if you want to like randomly pick it up without collisions, it should be big enough.
Yeah.
Yeah, I think for at least like swapping the relationship IDs, we did actually want collisions because I guess that's the same thing as having two strings match, right? They are collisions. So, but I think we should settle this in 18.5 because nothing would make me happier than to delete code. That's always a good day. So, so yeah, I'll just do that and we can.
That would make reindexing way simpler too.
Yeah, there's just
And it'll
fewer
make
hops and stuff.
SDLC indexing super simple.
I agree. Yeah.
Anyways, okay, cool. So that we'll put a pin in that as well.
Yep.
Where do we leave off? That was a good question though. Makes sense.
We wanted to go over the SDLC graph and why it throws a wrench into everything.
Yep. Not necessarily, but any questions on the architecture? Does everybody get it?
How do I handle SDLC between different namespaces? SDLC graph.
I'll lead you through what I'm thinking, but okay, so let's just jump into that. All right, so what makes the SDLC part tricky, right, is we have, for instance, here's a good example. Actually, let me just copy this. Move this up here. So what makes this tricky is we can have a group, and let's make this actually a nested group 1, and let's make this nested group 2. And we have projects in here. And we have a project in here. And this can be also, we can have another project, sorry. We can have another project. Right? So basically, if you look at this, imagine this is a top level group, meaning this is a top level namespace. The problem is this can have millions of nodes. So we'll just like make a bunch of copies, right? This can have millions of nodes on just one branch. This can also have millions of nodes on just one branch. And this can also have millions of nodes on just one branch. Right? And these are
Mhm.
like definitions, imports, all the stuff that would happen in a single project. The question is, do you create one Kuzu file for the entire namespace? Or do you create a Kuzu file up to this depth with a proxy node that you stitch queries together and run separate graph queries on the individual projects themselves? This part would include maybe merge requests as well and other related things. This part would include like definitions, imports, references, the call graph, right?
Mhm.
These would be all separate Kuzu files, right? So that's why SDLC indexing kind of makes this problem a little challenging, right?
Yeah.
Any
Like
question?
like if we treat each project, e.g. things that can have let's just say a lot of data for now, with respect to a call graph, could we just, if we imagine this, let's just say for simplicity's sake, as a tree starting at a sort of parent group, or sort of ancestor group, could we perhaps have everything indexed in one Kuzu database except the leaves, where the leaves are the projects, and then each project retains its own separate database with those proxy nodes that we talked about, under the assumption that when you query Kuzu, you can attach multiple databases to the same connection.
No, you can't. You can't.
Oh, you can't. Okay.
Yeah, I looked at that. I tried it. You can only connect one database at a time. You in this
Really? Okay.
you can attach a database. I'll show you. Detach external databases. And they should put this in freaking bold letters, but where is it? Um, suppose you're working in the middle of the session, you want to query uh, where is it talk about? Oh, here it is.
I'm assuming there's limitations. There have to be, right? Yeah.
Attaching aside from requirement. Where is it? It's like one database, or like drop or detach. Here we go. Yeah, so you can only have one attached database at a time, I think.
But that says for a remote. Because I see that it says after attaching a remote Kuzu database, you no longer have access to the original local Kuzu database.
Yeah, that's what it was, right?
But does that also imply the same behavior for
The local one.
yes, attaching locally? That's what I'm curious about. Because if that works, if we can attach n Kuzu databases to the same connection locally, we might be able to do that little carve out strategy that I just talked about.
Or we do the same thing as Federation,
Yeah.
Faith Federation, but in Kuzu.
Mm-hmm.
I don't know. Well, that needs a POC.
Yeah, that here, let me write that down because that should actually be pretty quick to test.
Is that like a Kuzu limitation? Because like if you were to use, let's say, another DB, let's say Neo4j, is that something you would be concerned about?
No, because that what I was showing you, linking to you guys earlier.
Well,
Um,
yeah, well then might be interesting to look for the right tool for the job instead of trying to.
Neo4j sounds big, so it should have a lot of stuff, right?
It definitely does.
Neo4j has something very interesting called composite databases. And essentially, if I show you guys the query, Mike, you might find this interesting. Let's say you have the example they have here is you have like product catalog, customer orders, right? And these have different relationships. You can specify a proxy node, but basically you can have two disjoint graphs and federate the data, right? So you can shard even against like different regions for like if you have in this case like compliance or something.
Hmm.
But essentially you can have two separate databases and literally query both of them in one query.
I mean, dude, that sounds like the right tool for the job.
Yeah, this seems very powerful.
Configure.
Luckily, there won't be too much rework in the indexer logic if we do decide to migrate entirely to Neo4j because of the more trait-based approach that we've recently the trait-based kind of infrastructure for all of the intermediate structs and the schema management that we set up. It shouldn't actually be too much of a hassle to, you know, to essentially take what we have now for Kuzu, but port it to
Yeah. Well,
And
maybe keeping
sorry,
both is also like
one
I
thing
was just gonna say keeping both is maybe an option. Like maybe for the local version, Kuzu makes more sense.
no, local version we do Kuzo for sure.
But
Yeah.
like for the deploy version, I feel like Neo4j seems like right now it just seems like the better option.
I think that's right. Yeah.
But before we get there, we have to do a little bit of due diligence, right?
Of course,
I'm
of
gonna,
course.
yeah,
Of course.
I wrote down the attached POC. That should be one of the first things that I do just so we can get this question sorted quickly too.
And the one thing I wanted to say is what's unique that we can do for the data organization is we can even think about creating one graph, but you shard at a particular nesting level or a particular group or node limit, right? So if you have
Yes.
a 500,000, some customers have 500,000 plus projects. So we can think about sharding it, and then you just run the query on both shards and combine the results.
Yeah.
So could be very interesting in that way too, right? Or like the system is responsible for analyzing how many nodes do you have in this shard? How many nodes do you have in this shard? Let's balance them out, right? Or something, right?
Yeah.
Oh, sorry.
No.
It's
Please go ahead.
called partitioning, and it's super popular approach for like large scale databases, like document databases.
I was just going to bring that up, and
Yeah.
something to also investigate is that whether the partitions are maintained like automatically if we actually have to in using Neo4j, if we have to append something to a certain shard or partition specifically, or if it works more like Postgres where
You declare the partition.
you declare the partition ahead of time, and when you insert something, if it's a timestamp based partition, will automatically be inserted in the right one. So that's something that we should do research into as well.
That's what I'm saying. It's good. We can all split up all the research work here, right?
Yeah.
I can take the charge on maybe even answering this question if you want to. But
yeah,
these are all different questions that we need to think through. These are just things that I've been researching, essentially.
That's good. It's the right place to come up with it's the right place to come up with a list.
These are the engineering challenges that we have to solve, essentially. But once they're solved, like that's where we're on the money, essentially.
Oh yeah.
Okay, so makes sense conceptually as what the problem is for why we have a problem in doing one namespace graph. Now, if we can shard or partition by node count, that really sets us up for success. Again, we have to look up that, and we have to examine what's the best database. There is also June something, June graph. No, it's not June graph.
But for partitioning, like from my experience, at least for like DynamoDB or like Cosmos DB that has partitions, if you assign like good ID, like good random ID or like calculated ID for each namespace or like group or project, it will put everything into one partition, and then it feels like it should split them into two partitions on like hardware level. It will just do it automatically, like rebalance.
Hmm.
So it's just a matter of having like good calculated ID for each project ID for each project or group or
The
namespace.
problem is I don't think we can use a cloud database because it needs to work for self-managed customer.
No, what I mean, like for example, Neo4j, I suppose it might have something like that already, like
Okay.
built in.
Yeah, where it does like the graph balancing. Yeah.
Yeah. That's a yeah, again, we need to investigate that and also push Neo4j too. Like how many billions of nodes can it handle? There's also memgraph. That was the other one. Look, we should look into memgraph because it's a lot faster than Neo4j. They claim at least. Used by NASA. It's just basically a C++ version of and in-memory version of Neo4j.
Nice. It's like a Kuzu competitor essentially.
Yes, yes. But it's a service based, right? So the drawback, we have to be honest here, the drawback of choosing a different database is we might get a little pushback for, okay, that's another thing that needs to have uptime, um,
Hmm.
monitoring, etc.
Uh,
status.
yeah.
So that's going to be something we might get pushback if we choose another database. But when Dylan, Griffith, Dimitri, and Jan and Omar and I were talking about it, they were like, it doesn't preclude us. And why are we not precluded from another database? One of the main reasons we chose Kuzu was because of the isolation, but we know that we can create shards or composite databases, I think Neo4j calls them. Um, we can create it at both the customer level and the namespace level, and we can create it at the project level. So we can create a new database. It's literally just a command in Neo4j for a new project, basically at a project ID. Whether it can store like hundreds of thousands of different projects, I'm not sure, but either way, like we can look into it and think about it. But yeah, so that's basically that. Memgraph is also very interesting. Again, we need to figure out these things like ASAP. That's the only problem here. And it might be good that Kuzu, it might just work that Kuzu can take attach multiple databases and we don't have to worry about the sharding issue. I just don't know of any way of like true partitioning in Kuzu. I don't think it's possible, right, guys?
Yeah, it doesn't exist because I mean it's essentially file based. So yeah, I don't yeah, I doubt that that'll work.
About Kuzu, I'm very worried about that it's file based. So you always have this over network attachment to volume, and
Yeah.
it can be a very big issue for like
Yeah.
large scale, like how to manage that, how to just imagine like you have to upgrade your Kuzu, like you upgrade Kuzu from 0.11 to 0.12, so you have to recalculate everything.
Mhm.
Um, or you have to like store some metadata, so you know versions at which you build the index, or something like
Yeah.
that. Um, you have to load the whole file just to know what version of the file it is, or something like that.
Yeah, that's behavior that we need to look into as well, is if their file format has been stabilized. I doubt it because they're still working on pretty low-level stuff. Like again, like column segmentation, that is something that you'll probably need to do like a force reindex for. It's probably
Yeah,
not
and
backwards compatible.
also that we had like seg faults, like when we had like dynamic library of different version
Yeah.
and compiled in another version, we had seg faults. So it's definitely like, and it was only minor version change.
Yes, that's exactly
So
right.
it's
Yeah.
potential issue.
Okay.
Yeah.
Yeah, these are good points. So we need to have a whole discussion on this and figure it out ASAP.
Yeah. Also, and this is something that I'll do in the attach investigation. Even if we can't attach end databases, I will also investigate what the limit of that is,
Yeah.
both in the code base for Kuzu. I'm saying like just looking at their C++ code, but
Yeah.
also just practical limitations, because it might be that we can't actually attach, 500,000, separate projects.
Like you guys got to think we might be in the billions of nodes territory.
Yeah.
So if we want to do this right, like we want to ingest, labels, we want to ingest like commits, we want to ingest all the things later on. That's why this is a data engineering challenge. And that's why it's crucial that we treat it as OLAP, not OLTP. And the current architecture is a little bit more towards OLTP, but the reason why we did that is because we've been thinking it as a search problem, but it's actually more of an OLAP problem. You guys know the difference, right? I know the difference, but Bogdan and Jean-Gabriel might not.
No, I
Yeah,
haven't heard of it, but like I'll figure it out. I'll just read.
I'll tell you. It literally is really simple. It's just OLTP versus OLAP. Basically means OLTP is like Postgres. It's transaction based, relational, right? Trade tables for XYZ. OLAP is like for larger aggregated queries.
Yes.
And
Yeah, it
so
makes sense like for data analysis and stuff like that, rather than
yes,
like DBs where data integrity is important.
yes,
Yeah. And then also a good way to think about the paradigm is OLTP is write frequently and read frequently. OLAP is read frequently and write infrequently. And when you write, you do it big, you don't do it piecemeal. That's
yes.
the difference. Yeah.
That is big difference. Yes. All right. So that is that on the SDLC, but that's not just it. So this is the problem. So there's the database question, right? Um, so we have the database question, but we also have two other major things that when you talk about SDLC, what are the challenges? The other challenges are what's the first one to bring up? How do we get the data from Postgres to the service? Right? And creating a new task in the table, in these tables might not be the best option here. And so Dimitri and I were thinking basically, what if we use Postgres triggers, right? Well, Postgres triggers is actually the same thing as this thing called Project Siphon. Whoops, Siphon. So I'll link this to you guys. I want you to get familiar with it. This is where we can partner with data engineering and essentially what Siphon is it's part of a larger thing called what is it? I should know this. Data Insights Platform. So if you guys just look at this architecture here, I'll explain it to you. again, I'm brain dumping like literally a whole month's worth of research in like 2 hours. So I'm sorry, guys.
No, this is good.
And I need to write all this down, but it's good I'm talking about it because now I can just I can AI summarize it. But so basically, this is what I talked with Dennis Tang about today, and also Nitin. So we have this data insights platform architecture, and what it's built as basically is just like Jean-Gabriel was saying, like, okay, what if you get a burst of tasks, right? How do we handle that load? How do we guarantee like exact ones processing? How do we like all the data race conditions that can happen, right? And if you're feeding directly from Postgres, that's where you can run into issues. And so what we can do here is leverage this platform as the data pipeline, essentially. And they're already using it they're starting with usage-based billing, but I was talking to Dennis, and basically this could be another good way to kick us into using this as the primary way of consuming the data, the SDLC data, merge requests, etc. Dennis's suggestion was when we do this proposal, pick one really good use case that we can iterate on. If we start out with, we're going to index all of the data, like we're going to index merge requests, issues, etc. Like people are going to shoot it down. But if you say, we need just this data, we need these relationships, and we want to subscribe to them, then we should be good as far as like getting pushback. But essentially, again, I'm not too much of an expert, but based on my reading of it, Project Siphon basically creates it runs on this NATS server. Are you guys familiar with NATS?
I actually don't know what Nats is.
So are you guys familiar with like Kafka?
Yes.
So Kafka, I think I forget what it's called. I think Kafka has topics, right? And Nats, I think, has subscribers. You guys should know Kafka. You guys are Java people. You should know this stuff.
I know it's just pub sub service, basically.
Yes, it's a pub subservice. That's what Nats is, essentially. And it allows us to do actually a lot of really cool things, powerful things in the future.
Yeah, that's why like I wanted to ask you a question why we need a queue in Postgres if we can have some pub sub service running, and looks like we already have it.
This is exactly why like I would think we can still go with the architecture, but we just have to be mindful that like for SDLC service stuff, we probably will be leveraging this, is my guess, versus using task table in Postgres, right? And if we're doing that, maybe it makes sense to also pipe the code indexing tasks through this pipeline as well. I don't know.
Interesting. Yeah.
It like for example like Kafka or any other pub sub services, but they allow you to like lock tasks, for example, and if you, for example, abandon a task, it will get back into the queue.
Yeah.
So it resolves like issue of a
The
lot of
data.
instances picking up tasks to do for
Yeah, and
innocent
usually
stuff.
like monitoring this stuff is pretty easy as well. Like they'll give you metrics and you'll be able to set up
Yeah.
stuff
Yeah.
way easier than with Postgres.
So there is a way to like siphon stuff from Postgres, like anything that gets created in Postgres, we just put that into pub sub service, right?
That's what Siphon is. So Siphon is a way it reads from the Postgres logical replication stream.
Mm.
Okay.
And see, this is where it's good that you guys are all database guys to some degree and have experience because like it took me a second to wrap around it, but hopefully you guys can just understand basically it create like you subscribe to the tables that you want to
Yeah, that's smart.
get events about. And for us, this is great because then we can also this enables something really key, which is upgrading knowledge graph outside of the Rails instance because we can just handle the new instance version and those data changes dynamically in the code itself, and the ETL mappings.
Yeah, this is good. I
Um,
saw that they have
Or
you can
even
set up
if we want to get,
oh,
sorry, if we want to get even
um,
fancier in the future, this is not a problem we should start with. Rails can declare the schema for the ETL transformation. So when I'm a merge request, I'm updating the merge request table. I also update the ETL transformation schema in my knowledge graph, in the knowledge graph part, in the same Rails instance. Then when you upgrade Rails, knowledge graph restarts and picks up that schema change and knows how to handle the new data. Like that's
oh,
something
that's
we can
cool.
do later on, but that's just me getting really fancy. But yeah, like there's a lot here, but makes sense so far.
Can we
Yeah,
deploy our own Siphon instance, or do we have to leverage the one that's already there?
Um, Based on my conversations with Dennis, we would hook into the existing deployed site.
Right. Makes sense.
I guess the question is can it handle the volume of data that we want? Like
Can it
how
scale horizontally?
This?
Yeah. Yeah, does it scale? Then because that's essentially
Yeah.
like Mike's question. Probably does, right? They're using it at scale.
I mean, they're using it for usage-based billing, so
okay,
Yeah.
if it's that granular, then yeah, it'll probably support our use cases. Yeah.
The question is how much data we want to bring with the task. Like, is it going to have like the whole MR like
that is the
content,
other thing.
or is it going to
That's
have a reference where we have to go to Rails or Postgres and
Oh no, 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 no,
query
no.
that, which is pretty difficult task, right?
no. So this is the next question, guys,
Yeah.
that we'll need. So let me talk about the security because that's the other piece
Oh, yeah.
we need to think about that I've been researching. There's many layers to this onion. It is like literally building a full business from scratch, basically. Uh, so here is the other part. I could have access to this group and this nested projects, but I could have no access to these,
Right.
right?
Yeah, the same way that yeah,
You could have
that we
access
can't see some repos that
have
people are
access to
they're
this
working on.
layer for nested group one, nested group two from the parent group, and no access to the project.
Right.
And then in the project, you can have multiple issues,
Yeah.
and one of those could be confidential, and you don't have the permissions to see that confidential issue.
Yeah.
Is
How does access control kind of work in Postgres now? Because I feel like if we
It's
start,
all of
top
that is
down.
embedded in the Rails application. I learned that a few weeks ago.
Okay. So the
That is
roles
the
are
whole.
not Postgres based. They're like essentially processed in Rails, and then that spits out what
Yes,
data you have access to. Okay. I see now why raw access to the database is not something that anybody has except the infra people.
exactly. And that is
Okay.
for code green, code purple and code yellow and code purple.
Hmm.
That is why they're building an auth service. There is no centralized auth service.
Ay,
That you
I
can
hit the
say,
Yeah.
wrong
here's
guy.
my group, here is my user. What projects and groups do I have access to?
your issue is, I guess that's why you, I guess, yeah, I guess that's why you to reuse the Rails, like Rails for permission.
That's
So
why
basically, when
here,
you query the data, you could validate the output. But oh no, that's a mess because then the Rails app has to know the
but
output.
this, I'll
Yeah,
tell you
that's a
what,
mess.
yeah, I'll tell you what, now you guys are starting. This is awesome.
Yeah, it's
It's
messy.
awesome leading you guys through exactly what I've been, Dimitri and I have been thinking about. So basically what we are thinking is there's two ways we can do this. There's this thing called, back to what I showed you guys, the namespace. Read again this namespaces thing. The reason why they built this is because we have no auth service. And so in Elasticsearch, and when they're indexing stuff in Elasticsearch and they're indexing stuff in Zoic, you have to replicate GitLab's permissions structure to some degree. You just have to. What our kind of hack solution is, until the auth service is a thing, is basically there's two key pieces or three key pieces. The first key piece is that we would embed these things called traversal IDs in all of the nodes that are ingested into the SDLC graph. These traversal IDs already exist in Rails. I'm pretty sure they do. So when you create a new namespace and you have group, parent group, nested group, project, that's one traversal ID. So you can think of it as a tri data structure. Does that make sense? Bogdan?
Yes.
It makes sense. And it's actually, it does, I think, like it creates a tri data structure in Rails. So we would basically need the same traversal IDs to be copied through that data ingestion pipeline. So it makes it into the graph somehow. That helps us handle data reduction, but it does not prevent all permissions because it only handles namespaces.
Right, which are, yeah, I can see how they're not one-to-one because the scope of Zoic is just for code search, right?
Right. No, but the main
Yeah.
point that I'm saying is basically it handles up into the project level,
Yep.
but it does not handle all the nested permissions that can happen in a project.
Yeah, I
If
see.
you have access to issues in that project, do you have access to confidentiality in that project? All of the authorization stuff. Do you have the correct role, right, for this project? All those things are checked on the Rails side. So what we would do and this is what I was talking to Mo, one of the security guys, about it, for now, is we would create a redaction layer. And this is the only way you can produce, you can avoid S1s. Basically, we create a redaction layer that so the first key point is the traversal IDs. Does that make sense so far? So like an example would be this would have group one, parent group would have traversal ID 1, right?
But like, what do you, so like, just to go back for when you're talking about like confidentiality and stuff, do you just not index it until we have a proper solution? I feel like that's the right move. Because like these traversal
we
IDs are not
would
going to.
still index it. Hold on, I'm getting there. I'm just making sure you guys
Okay.
understand the traversal IDs. The main point is basically with traversal IDs, in any of the queries that we do, we can input the traversal IDs as a filter, and the filter basically like reduces the amount of data you have to scan that you have access to, because not every user has access to the entire namespace, top level namespace, right? So you would do a query against what you exactly have access to. There might be problems though with that. Hold on, guys, 1 second. Someone's calling me. Give me 1 second.
You're good. Here, I'm gonna go to the bathroom super quick. Just give me a minute.
Okay. Yeah.
Sorry, guys. Mike said he's going to the bathroom.
Yeah. So about confidentiality, we are concerned about confidentiality because if we have like let's say single database, let's simplify, and users asks do ABC question, it should not be able to have access in its tool call to the data that is this user doesn't have access to, right?
Yeah.
This is the whole point of the discussion.
Yes.
And because Rails is MVC application, all the permission model comes from Rails logic. We don't have something like JWT token that has scopes, like access scopes to different parts.
Different resources. Yes. We don't have an auth service
We
for all.
have We have to ask Rails, do you have permissions to this page, basically, every
Yes.
time.
Yes.
Which is super messy when you have millions of nodes. You cannot ask if you have access to millions of
Even
nodes.
if you add a node service, you'd still run into some issues because like when you request something, you're going to go through like a lot of relationships in the graph. Like you don't want to stop each relationship to check, do you have the ability to
No,
like,
you guys are completely right. So that's why we're thinking basically the traversal IDs cuts the data down, right?
yeah.
Filtering. The only issue with that is we have to
All
add
right.
filter IDs to every
I'm
single.
back.
Hey, Mike.
Hey.
The only issue with that is we'd have to add traversal IDs to every single query. The other thing is the redaction layer. So in Kuzu, I kind of was showing this in the SDLC performance analysis. We have to, or in Kuzu, whatever graph database, basically the main thing is as long as our query returns the entire node, or at least the ID, minimum it needs to return the ID and the type, sorry, the ID and the resource type. As long as it returns the ID and the resource type, so I have no like issue node here, right? And it'll be like ID, it'll be description, type, it'll be type of issue, right? Description, title, all the other metadata. And then I have MR node. That merge request node has ID, type, merge request, description, title, right? So my thought is if we can create a redaction layer, where as long as the cipher query returns the actual like full node, we can essentially, if we go back to here, this is where I was talking about with Mo. Actually, I didn't properly illustrate this. Essentially, as long as you have the ID and the type here, at query time, in your results, you basically check against Rails.
That's going to be so slow.
Yeah, that's the main issue. Is basically you check against Rails.
I knew you were going to go there.
You have
But
basically, yeah, no, hold on. You have basically an array of
too
your,
slow, man. That's too slow.
you have
That's
an
too slow.
array of, first you input the user object or the composite identity, and then you have the array of IDs, and the resource type. And it would be an array of these against the Postgres lookup. And then it would just filter out any of the nodes that the user does not have access to.
But like that's risky
It's the only
because
way. I think that's like, I don't know. It's the
yeah,
only way we could think of, but I don't know if
yeah,
it's a smart
yeah.
way.
Right now we're limited, but it's risky because not every access or whatever is hard coded in Postgres. So like some rules are like programmed in Rails, not in the DB. So you also have to take that into account when
No,
you.
it would run against the rail a runtime. So you would create an endpoint for a merge request. The type would be merge request. The ID would be the merge request path. You would do can user access.
Yeah, that makes sense, right? I thought you were going to do that against Postgres. And I was like, that's not going to work. But yeah, that works. It's just painfully slow.
Yes, it would.
That's like almost as slow as stitching up the data in real time, is my concern.
What do you mean stitching up the data in real time?
I'm curious if like I was just I'm curious what like I don't know how fast it is to validate permissions in Rails. Like is it like super optimized where it just queries the data or does it query like the whole thing and then just like the whole record and then from there looks up the relevant field. Because my concern is that if you're going to load the data anyway, you could just stitch it together.
Dimitri is saying it could be as fast as like 50 to 100 milliseconds.
Oh, that's good then. Then there's no
Yeah.
issue.
Yeah, especially if it's composite. Yeah, I think
My only
that's
concern is like
that's fine.
if we're talking enterprise scale database, I don't know how quick it is to query like a project, an issue, a merge request.
Is
It
there
could
a
be
way
fast.
is there a way to have a monolith node that's just dedicated for permission checking for us? I mean, I know that's jank, but you know, if we're thinking about the enterprise scale, it might.
Well, yeah, like, yeah, are you saying creating a separate Rails runtime?
Yeah, that's just
Like a preview
for
worker for dedicated for knowledge graph lookups?
To be
for permission
fair,
checking. Yeah.
to be super fair, if there was like a not service written, whatever, Rust, Go or something, it could like this could not be like a non-issue. It's
It'd
just
be like
like
a
the
nanosecond.
Rails.
Oh yeah, if we had
Yeah.
an off, yeah, if we had an off service, it would be literally a non-issue. But
And do you have any idea of timelines for the auth service? I imagine it's not.
oh, that's a 2-year project for sure.
Okay, yeah. So okay, so nowhere in scope for us. Gotcha. Okay.
Well, I mean, what are the use case for knowledge graph? Is it like is it to perform research or do we see something like what are the
It's for agents, right, to have access to the data. But the problem
okay?
is agents can't just have access to every single thing.
Then I think the delay is not that big of a deal in that case because if you're kicking off some sort of research, you kind of expect some delay. I
Yeah.
think like
Yeah,
it's acceptable.
Yeah,
in that case.
we're just crazy performance obsessed, which I think it'll be good. We'll probably find a lot of skeletons in the closet, but
for sure.
No, but yeah, but for a research use case, it makes sense because you expect it to take like some time. So that's all good. I think we can live with that.
Yeah,
Uh,
especially if we're batching permission checks, I
yeah.
don't see that to be that big of an issue. So I think we'll be good.
What would have scared me is if it was like something that like would power multiple services outside of AI. So like it could do these like mass queries or whatever whatever like use case outside of AI, then it'd be super long. Way
well, yeah,
longer than
no, yeah, but in that case, you would expect the caller to have admin permissions, and like if you want someone to
yeah.
do admin reports, right? You would just expect that there would be no authorization checks. Then you can just skip that whole layer entirely and run aggregation queries.
Yeah. Yeah, you're right. In the context of AI, I don't mind the workaround. It makes sense, I think. Actually, it makes more sense. It makes sense. It's all right.
So yeah, that's what our thoughts are. But if you guys think of any smarter way to do it, let me know.
I mean, it's tough because there, like I said, if it was stuff hard coded in the DB, it would be easy. But there is like business logic rules
And that's
that
the thing is like the
that
other
you can.
option that you could think we were thinking about doing is embedding like you theoretically could have a thing where you basically have a user node and that user node is always the entry point for any query. And you check what that user has access to. But the problem is you have to synchronize all of the user state. So you're synchronizing Postgres user state. And that would be
Yeah, and also like if there's a new permission created, you have to update it.
yeah,
If there is like if a permission changes, you have to update like invalidate everything.
yeah, it's just
It
a bad idea for sure.
no, yeah, let's
So
Rails it is.
it no longer gonna be a direct MCP call to the knowledge graph, right? Because you cannot just let duo enter username
No, yeah.
So that
on
was the other
behalf
thing I was going to show you.
of user, right? Because someone can force it into entering admin user in a query, right?
Right. So this is the other thing I was showing you guys. So if we have a cipher query logic, like the LLM can basically input a pseudo cipher query, we can essentially always ensure that whatever is traversed in the graph always returns the full node. And because we always return the full node, we just do a recursive scan on the output JSON and gather the IDs and the types, query Rails for those, and then redact any of the data, basically.
That makes sense. That turns into like a
Yeah.
one-shot type thing. Yeah, that's nice.
This is
Okay.
this is one way of letting the LLM, explore what it wants.
Yeah.
Yeah, like gives it a manifest. Yeah, I
But
like
this is
that.
a little bit more crazy because you have to turn this into a cipher query.
Well,
So
that part is not as complicated as you think. If you have, I can talk about this later and help you co-design it, but you can use things called parser combinators, where you essentially have an input grammar, right, that you define ahead of time for
yeah,
a schema like this. And a parser combinator, all it does is it takes one parser and turns it into another parser. And you can use that to generate a cipher query where it's like a nearly one-to-one mapping. Obviously, it depends on how nested this is, but I think that that part, if you use like the right abstractions, it actually shouldn't be that difficult. And we can make it sort of mathematically correct to where if, even a character is off inside of the actual JSON schema, we would get a very specific error being like, hey, exactly this node is wrong, right? That sort of thing, without needing to do any of the crazy logic ourselves, with nested parsing and permission checking.
yeah.
So that I can help with whenever you're thinking of doing that, if we decide to go down this specific route. So
Yeah.
However, like I'm going to switch to some different stuff, but again related. How are we going to kick off like all the data indexing? Are we going to just index like everything, and then just do incremental indexing based on queue, like tasks that we discussed?
this is a
That
good question.
that I need to ask Adam and Dennis and how Siphon works, because it might just be up to how Siphon works.
That sounds right. Yeah.
And in the Zoic architecture for code indexing tasks, the way they do it is state transitions. So like it handles like a state. If you get a state transition, it knows to just reindex everything. But like if we do it via the NAT server, like I think in Siphon, if you guys read it, it can do like an initial data snapshot, right?
Yeah, because I was gonna ask, because I was reading up a little bit on logical replication streams. Like they didn't talk a lot about getting an existing snapshot of the database. It's just the changes to the database. So yeah, we want to make sure that we capture both.
Yeah.
Um,
Does logical replication stream cover the initial database?
from what I understand, it sends row by row changes, inserts, updates, deletes, merges, or the equivalent in Postgres. Yeah, I guess there'll just be update, but it doesn't it doesn't say much about the initial state, like the state before the stream starts, or wherever you start subscribing to the stream. So that's just something that we probably want to look into.
Yeah.
It's focused on changes.
Yeah.
Yeah, but it would be nice to have the original state because, if we start at time t and, you already have a bunch of epics and issues outlined, it wouldn't do us kind of that much good, right? Just to have the changes. We'd want
Yeah,
the
I
original
think,
state.
to be honest, I think we can't go live without the original changes. I think that's like the big selling point.
Oh yeah, we
It's
can't.
like,
You have to replicate.
Yeah, do like a full kind of replica. Yeah.
Or like a way to replay all the events at least, right?
might be a dumb idea, but you could probably like discussion fighter, but you could probably use like a backup or something. I know because you have to filter the data you get it. There has to be something already set up that we can leverage.
I think
Yeah,
so.
I'm worried about like initial hit on monolith in Postgres when
Yeah.
everything kicks off.
Yeah.
Yeah.
Like knowledge graph can handle a lot, especially if you give it a lot of nodes hardware. But how much can handle monolith and Postgres? Uh,
Yeah, that will be
uh,
something. Yeah.
I know
Yeah.
that like full replication behavior for like Postgres, like if you're copying a database, I think it's not an exclusive lock on the database. So I think it just kind of
No.
does best effort. It will lose some transactions and stuff like that. So it won't be like entirely
We do
perfect state.
handle snapshots, guys. I see the snapshot manager.
Oh, okay. So it allows like a okay.
Yeah, I wonder if you can just work with snapshot and then switch to like live data at some point
I think yeah,
with all
Yeah.
different with all missed events
That's what
siphoned.
we would want. Yeah.
It looks like it does scans.
Okay. If it does scans, then great. Then
I don't know, like I don't know. We have to ask Adam. That's something we'll have to sync with Adam with. Adam's the tool for
I
site.
think they already solved this issue. Like, I'd
Yeah,
be
they must have,
surprised if
right?
they didn't think, like, if this isn't solved, I'm very surprised. I
Yeah.
think it's solved.
Yeah.
But I'm very
They
judgmental.
have to because there's so many, just like knowledge graph. There's going to be other OLAP applications that need to read.
Yeah, I'm sure if we ask them, they would guide us because it can't, like, there's no way it's not solved.
Yeah, just having a stream of diffs is not super useful. You kind of want the original. You
Yeah,
want the original
yeah,
data set,
exactly.
right? Yeah. Okay. Yeah, so we'll just ask him that.
But
Yeah,
yeah,
it's
that's the SDLC stuff at a high level.
one thing
Yeah,
I
that's
wanted to
it.
ask about, because I saw this is Siphon does seem to have like support for like, third-party connectors, essentially a custom way to dump out the data. So we'll probably want to work with them on that. If you pull up your diagram for the STLC graph, or no, it was actually just the Siphon. I think you had something about Siphon.
Yeah.
Yeah, it was the one with Nats. It was under the data insights issue. Yeah, you see they have custom exporters. We'll probably just want it to be dumped as what, Parquet files or something like that. Although they might already do that for the S3 exporter, so we might be able to reuse that logic.
Yeah, I don't know. Maybe it might make sense to dump it as Parquet and yeah, I
Yeah,
don't
instead
know.
of going to ClickHouse, yeah.
No, we won't be querying from ClickHouse. We'll be subscribing to Nats directly.
Okay, gotcha. Yeah. Okay. So then yeah, we'll have our own custom exporter then, for sure.
Or
So,
consumer, I think is what they call it.
yeah. Okay, cool.
I don't know. Maybe it might not make sense to consume directly. I think it might make sense to consume directly, but I'm sure Bogdan's making a face, so he might disagree. But
We consume directly, we can index directly, right? Those just end up being tasks.
I think what's gonna happen is we're just gonna generate like tasks for like tasks that knowledge graph should do. Like it should index this, and this based on what we get siphoned from the Postgres. So for
Yeah.
example, if user edits merge request, we should index merge requests, right?
And is
Um,
that something that, again, it's just a question for future discussion, but would we want to write, like that MR data from a replica of Postgres plus the diffs to our shared volume? And then when the knowledge graph indexer gets the task, it knows where to look inside of the volume to actually index the data and put it inside of the graph. That's what I would imagine would happen.
oh, I see what you're asking.
Mhm.
On the
to me, it
same,
makes
go
to me
ahead.
it makes sense that task contains a reference to what should be indexed. In this way, it will be much easier to implement, for example, reindexing, like whole reindexing infrastructure where you have something like a crawler that's gonna go through like everything in GitLab and insert the tasks for everything that gets discovered. So you
Agreed.
will have the same shared pipeline of indexing everything.
But this also, we want to be careful to actually, or yeah, we want to be cautious to avoid actually getting the raw data from like through Rails, right? We essentially just want Rails, as we said, as like a permissions layer, right? So maybe we do want to keep the raw data, like write it immediately to our shared volume, and then
Yeah, so that's what I talked to Dimitri about. We were like, we can either store the data in the graph, like the descriptions, like just got to use practical examples, guys. Like,
yeah.
we have these two nodes, issue node, MR node, right? Is your question, do we store the descriptions in the graph?
I'm saying that through the logical replication stream, right? Let's say that somebody creates an issue that not everybody else has access to. Okay, great. We get a bunch of data from the logical replication stream from Siphon, and we have our custom connector that says, okay, I'm going to write all this big batch of new issues under this specific group to a Parquet file. Okay, then we send the Parquet file to our shared volume. And at the same time, we send out a task to the GKG service saying you need to actually index
Yes.
yeah,
Right.
those specific issues, right?
Yeah,
So the question is how much data is being persisted to our shared volume? How much is Rails doing, in this analogy, and
yeah,
how much
the
is Siphon
data
doing, right?
completely explodes depending on whether we save large things that can be large. So description,
Yeah.
um, title. Title is actually not that big, I think. I think there's an upper limit on your title, right?
I think so. Yeah, I think it's like 300 something characters.
Um, so like we just need to think about, are we gonna store big stuff in there like descriptions, comments, um
Yeah,
We
because if we do it like if we depending on how much we do ahead of time or not, we could end up putting a lot of strain on Rails if we're, getting it at sort of index time. So that's just the one thing I want to avoid.
yeah, we need to like Bogdan was saying, we need to choose what data is coming from the NATS
Yes, I agree.
stream, and we need to choose, are we going to store the data in the graph? Those are the two questions.
Yeah, those are two very good questions.
By
Yeah,
the way, we also
sorry.
need to think about no, go ahead, Bucket. I'll say that.
Oh, no, that was it. There's probably some lag. Yeah, that's it.
Yeah, we probably need to think about like what happens for the data we missed. So like it didn't exist in Postgres at first. It got inserted. Somehow it didn't make it to us. And then like how do we recover from that is something we need to think about. Not sure it's going to happen. I don't know like much about the Siphon architecture, so maybe it retries until all consumers have consumed it. But
Missing from Postgres and what? Say that again.
well, there's a case where something can be inserted in Postgres, it goes to Siphon, and then somehow we miss it, we don't consume it. Like we're down, service is down, or whatever. Like we need to think about like the gaps. How do we fill the gaps when they happen?
Okay.
Because they will happen. There will be gaps for one, like for sure. It's probably already solved, but we would need to think of how they're doing it.
Mm-hmm.
That's
This-
that's NATS, isn't it? That's the role of NATS.
Yes,
I don't,
this
don't
is
know.
why PubSub service should have like 9999 uptime. Because at this point, it's usually a source of truth. It's a service that manages the logs of the tasks. So if, for example, knowledge graph indexing is down or indexer just crashed, it was indexing this, and this task, and it crashed, the PubSub will not get notifications that this task finished in time, and it will re-add that to the queue. So when we
Yeah, if it
recover,
works like that, then we're good.
It's
yeah,
PubSub, yeah, like you can, it's literally like I think a gRPC connection to the NATS server. So you can,
yeah, it works. Oh, sorry, yeah, it works exactly like that, but the biggest constraint here. We should have our pops up service like with really good uptime.
Yeah,
That's
because then to be out of sync and then could be a mess to recover.
yeah, it's really known like issue like in the world that pops up services should have really good uptime. So hopefully,
Worst case, we create an index all task, and it just deletes all the tasks and restarts everything. I don't know.
I mean, for
we-
some namespace, it's a non-issue. You could reindex like every time it wouldn't matter, but for like GitLab, we can't afford to
yeah,
lose the data too
I'm
much.
super worried about like this first like kickoff phase. Like what we're gonna do? Like how to
Yeah,
ingest all this data?
we'll do it on
Well,
a Monday
just so you
morning.
know, Ogden, just so you guys
Right.
know. Wait, I can't say this because this is gonna go on the YouTube channel. Let me just type how much data.
Sure.
That's the amount of data that was indexed by Zoic. I
Just for
think
code?
that.
That's
And-
that's quite a bit.
And that's just code, and they did that in I can't say the number either. In
Just send the number.
Yeah.
that many hours,
Okay.
All right.
and that's Go. That's not our stuff either. So
No, but like if we go down the STLC rabbit hole, like regardless if it's Rust or not, it's just the amount of data. Like the scale is
It's also not about amount of data, it's about latency. Because we'll have to talk
also.
with Rails a lot.
Oh, will we for
Uh,
the indexing phase? I don't know for
like
indexing.
it's of course depends on how much data we get pulled into Siphon, like how much data Siphon gonna pull, how much data we're gonna pre-process for each task, because we generate task based on Siphon events, right, from the database. So for example, we have event MR changed by user. So what we're gonna have in that event, we're gonna have new content. If we have new content, how we get it. If it's siphoned, that content got siphoned from the database, so we don't have to do anything, right? We don't have to hit Rails.
Yeah.
But if we have only link, we either have to reach Rails by the task creator service,
Yeah.
or we have to reach Rails from the indexer.
yes,
So it depends how we design that.
yeah, that's what I was
This
asking.
could-
Do we store it in the graph database? That's the first question. Like, do we store
Yeah.
that content in the database? And if we don't, or if we do, how are we get it in the database? Is it going to come through the stream, or is it going to come through through some type of asynchronous fetching?
Yeah, so if we don't store that, we should understand that we have to query not only permissions from Rails, we'll have to query the content
Yep.
from the Rails for each tool call. For example, have 20 nodes in the results that user has permissions to. We'll have to do like at least 20 queries to get the content of these nodes from the Rails.
Yes, that's the other thing. So if we don't store the data in the graph, Dimitri and I were saying that same endpoint that would check for the permissions would also return the data.
And how good is the monolith at doing these sorts of
I don't know.
batch queries? Yeah, because they can be pretty deep. I mean, these things can be pretty deep. There's a lot of data that can go into just a single query.
There is a lot of data, but I suppose they're gonna not gonna be deep. They're gonna be like pretty specific API calls, like get MR, right?
Yeah.
Yeah.
MR content, get comment content.
Yeah.
But wait, why are we talking about this? Aren't we supposed to get this data? Like, are we supposed to already have it? Like, we're not going to pull the data from API calls. Like, that's just never going to end.
It depends what we ingest into
Depends on
indexer.
what we design to ingest in the
Yeah.
graph.
Like
You
what
mean the
Siphon
initial, like
gonna
you mean the initial? Oh yeah, I mean yeah, for Siphon, yeah.
Physical data in the
Sure.
graph. Like, are we doing description? Simple use case. Are we putting descriptions in the graph? That's the question. That will inform the rest of ingestion and query time. That's
Yeah.
what I'm talking about,
The-
right?
So there are two questions: what we store, and how we feed data. Do we give link to the indexer, or we give link and all the content to the indexer? Like two
Mm,
questions.
I mean, I think you want to have the data close, but might be
This is the $1 million question, actually.
this, literally. Um, okay, so storage is cheap, but we have to be very, very
Also, we
confident.
have to be mindful that, remember, if you're in a self-managed environment, that if we keep the content in the graph, we're going to be saying, yeah, you're duplicating your data.
Yep, pretty much 1-to-1. Yeah. That's a lot. That's a lot.
So now your storage cost has doubled.
Yeah, we would really
So-
need to trust that our schemas are well laid out in Kuzu so that they can, so each column can properly be compressed, and with really long strings, that's not a great guarantee, you know. You're looking at
Why
maybe
Something like Neo4j actually might be the move because it can handle those deployed environments.
I'm-
yeah.
I'm like 80 or 90% confident that we're gonna use something like Neo4j, because if we use Kuzu, we'll have to also build a lot of stuff around limitations of Kuzu.
Yeah. Yeah, like
And we have other bigger questions to answer, honestly. So
yes.
Yeah.
So the first one, I mean,
Interesting. It's a cool challenge, isn't it, guys? I think we can do it. I'm
I
very
think
no,
so.
of course, we'll have something.
We'll figure out something that works. It's just, yeah, it's like, I mean, the main concern about replicating the data as is, I mean, these are just real world like cost constraints, right? Because it's very clear that if we do it with Kuzu or Neo4j, like, you know, it's going to be fast. It'll handle giant graphs. That's not going to be an issue. It's just like, how much cost do we want to pass into our customers? Or if they're self-managed, I mean, sure, you know, it's going to be a little bit more expensive for them. I shouldn't say a little bit, it might actually double their storage costs. But, you know, will that be offset by them not needing to spin up more monolith nodes, because now, you know, they don't have to thrash the monolith to get all of this data. So this is actually very hard to predict up front, like what's going to cost more.
Yeah.
Also, do we plan
Because storage
on,
is cheap,
like,
right?
do we plan on forcing every self-managed user to install the knowledge graph?
I think it'll be
Like, what
optional,
if
right?
they're not Duo customers? Like, there will be self-managed custom, like people using self-managed that are not Duo customers and don't want to be. So we also have to think, like, do they want to manage another database, more storage for
it's
nothing essentially?
it's the same as runners, right? You can have your own instance of GitLab, but without runners until
Yeah,
you
that's
install
right.
them.
You're not obliged to run like the runner service.
Yeah, so I
So
guess in that case, storage costs might not be too much of a concern because people will just be opting into it. I mean, still a concern,
Depend-
obviously, but
it depends on of the increase. Like if it's a couple of cents, I think we can live with
Okay.
that. But if it's like like if it's noticeable, like that's another thing.
Can I get back to a really big question? Like
Mhm.
there's really no way to have like read-only replica of Postgres with maybe a read-only version of monoliths running. So it's connected to read-only replica of database, and we query this read-only version of monolith. Yeah, data might be like half an hour old at most, but
That's all right, I think. Data
can
being like
save a
up
lot
to
of
a day old is almost all right in my opinion.
because what I think about it is, so self-managed customers that don't have a lot of stuff, like if you compare like GitLab, um, like whole GitLab with some self-managed instances might be super small, right? They might have like 20 projects. yes, they might have a lot of code, but if you compare to whole GitLab that has a lot of different organizations, like enterprise organizations, is this going to be smaller? So we can provide them some options, like how they store their data. They can have either duplicated data, everything going to be faster for them, but they can switch to like not duplicated data, but in this way we'll have to query, maybe like do live queries on their database. So if they have small database because they don't have a lot of stuff in there, it will be much faster for them, and it's like viable option for them.
I think the economics of having duplicated data on our side still might work out in both the case of large and small organizations, because I mean, compute is always going to be a lot more expensive than, per gigabyte storage costs. So
Yeah.
this will be something that we
Yeah.
should investigate. I'm trying to figure out the best way how to investigate
Wait.
this.
Angelo, didn't you run simulations
On what?
on like issues and
I did,
like
yeah.
indexing with issues with
But
description?
that's
So
what
like,
I don't know about Neo4j.
yeah, but like with Kuzu, what was what was like the DB size, let's say?
91 gigabytes of uncompressed Parquet data. Actually, I don't know if Parquet is compressed, but
Parquet
And that
usually
was
has
like with
inline compression.
SDLC. What that was with SDLC data, right? Not
yeah,
only code, like
yeah,
SD
like
91.
fake RS or whatever. But like it generated seeming like decently long issue titles, decently long descriptions, the different properties on there. If you guys look at it, you can see. And I generated 91 gigabytes of Parquet data, and after Kuzu compressed it, it went down to 23 gigabytes. And that's for how many projects did I do? 20,000 projects.
Okay.
So how much is that in like storage cost? 20, or
3
let's say it's
gigs.
100 gigabytes, like worst
This is for
case.
an org that has 100,000 users, 2,000 groups, 60,000 projects, 200 issues per project, 1,000 merge requests per group, number of milestones per project is 4. Long description ratio is 5% of descriptions have a 1 megabyte description size, which is honestly probably a little ridiculous. That was me pushing it. Like, not many people are gonna have 1 megabyte of description. I don't know. Maybe they do.
But I mean, we could
For
just for that infer like a range that it would cost to add descriptions versus not add them. Like you
if we had
could
100 gigabytes of provision storage via EBS, right? Elastic block storage.
Mhm.
On the SSD, it's $12 a month.
It's super cheap.
Yeah.
Okay, then that's
It's not
Like-
including code, but let's say that increases by, 10x for code. $125 a month increase. I mean, do we know, like,
125 a month is substantial, I think.
but if they have like 100,000 repos, I mean, they're probably
That's a fair point. That's a fair assessment. I was thinking about like the small startup, just self-hosting GitLab to save some cost because they have like a Mac mini somewhere. But you're right that these people are not going to have this amount of data. Um,
yeah.
Yes,
yeah.
this is what I'm talking about. Like, show me an organization with self-hosted GitLabs that gonna have 10,000 projects.
There's a lot.
I mean, yeah,
There are
because
some orgs with like 10,000
There's
projects.
we can't say exact numbers, but
Yeah,
there
yeah.
are orgs with
Oh, yeah, I can imagine there are, for example, some organizations that do contract work, for example. Yeah, they like do.
some of them have like hundreds of thousands of projects.
Yeah, I can imagine that. Yeah, makes sense.
well, also, the knowledge graph should be opt-in the infra. Like we should make sure of that. So it's not a forced cost on our customers, first of all. I think
Yes,
that's like
it'll be
is super
optional.
important.
Yeah, yeah.
I think that's super important. And then we should probably check what's the cost difference between with descriptions and without. Like, is it negligible? How much is it? How much more is it? But then again, like it's obtained. I don't know. Um,
I don't know. To me, it sounds like if you want to have knowledge graph, you should understand that you will have duplicated data. It's like having an additional index on database. Like if you have additional index on database, your queries are faster, but you use more storage for a database.
Yeah.
So it sounds that you should understand like, okay, you want to use knowledge graph, you want to have super fast tool calls, right? Like Duo works super fast. Okay, please like 1.5x data is needed for that. I feel like it sounds reasonable, right?
Yeah, it's not a bad point.
yeah, and like good point. Like I don't remember who made it, but if you have a 100,000 project and you want to leverage Duo, you want to leverage like the knowledge graph for your agent, I think the increase is reasonable for
I
an
think so.
enterprise of that scale.
I think that's right. Yeah.
All right. I think that's it though, guys.
Cool.
Should we end the recording there? Oh, we have to go over. We already went over the work, right? Of what we're thinking about splitting up.
I mean, just at like the high level, if we want to dive deep into like what 18.5 looks like versus 0.6, and then just kind of going ahead, because I know that we're sort of feature freezing CE, but we should probably talk about exactly what that means and like exactly what still needs to be done. I'd imagine most of the code indexer infrastructure, the core logic is just going to be pulled out of CE and used in server side and in conjunction with the SDLC, but should probably just still talk specifics.
Yeah.
So you guys want to do that?
Yeah, we should.
Yeah, so let me show you guys the server-side epic.
Okay.
I just want to organize the epic a little bit more. This is what I was saying. I was saying like things need to be. Jan did a good job, but it was just one guy, right?
Mm-hmm.
Or him and Omar, but um, yeah, we there's like so logging and monitoring, right? This needs its own entire epic, in my opinion.
Oh yeah. Okay. Yes.
Just from the number of issues you'll create for the logic that we're
Oh,
putting.
me and Bogdan will handle the epic for sure. Like just by looking at the infra and like everything, this is an epic. This isn't an issue.
Yeah.
I
So
got a package I got to pick up real quick. Keep talking, guys. I'll be gone for like 30 seconds.
okay. So what do you think? I'll go ahead and create the epic, or if you guys want to create the epic, do you want to go ahead and create it right now? I guess I wanted to maybe move the knowledge graph server epic under its own. The main question here is like, do we wait for the data engineering team before we continue? Well, the observability stuff needs to be in either way. Logging needs to be either way, and it's going to be a K8 service. So like we can, I think, make those assumptions and blow those tasks out.
Right.
Oh yeah, I wanted to ask how where we're gonna host and deploy everything because it's important for logging and monitoring
On K8s.
on a case. Okay, so okay.
And that is why we're meeting in Frankfurt in 20 or in less than 10 days, actually.
Because for example, for Case, I know Case supports like Case can pull logs automatically. Like we don't have to do anything in code. So in Case, you can configure
Yeah,
that
we
Case.
use open telemetry. We'll use some standardized logging format, but all that stuff needs to be figured out. Like and we don't have we have no logic in the Rust indexer for that.
Yeah, yeah. What I mean, for example, for logs, like text logs, we don't need to do anything if we host in Case, because Case can just go to the pod and just you just specify what log file to tail, it will just tail that log file and ingest into, for example, Elastic all your logs. So you don't have to do any code changes for that.
Hopefully that's set up.
Hopefully, yeah, but we just need to make sure, and also make sure it's pluggable somewhere, right?
Yeah, we also need to figure out like
We have a
metrics and
Helm
stuff.
chart. We have a Helm chart that Dimitri's working on. So you guys will need to work with Dimitri as well on like it's going to require tight coordination between everybody. Because Dimitri's working on the CNG image and he's working on the Helm chart.
Yeah, that's all right. And about your mini summit next week or like the week after, should we like what's going to be discussed there? Is it like going to be, are we going to discuss how to deploy like a service using the knowledge graph as an example, or is
Yes,
it
exactly. And these questions, this is why I want to kind of redo the epic around these questions. So
right?
service architecture, right? What are limitations getting the service deployed? What standards could we ensure the service can properly talk to one another? Like we need to have all these points answered.
So hopefully by the time you're there, me and Bogdan would probably have a good idea of what needs to be done and what we plan to do. Should we? Yeah, obviously we'll share it to you, but should we hold off on doing anything before like this meeting's complete?
I think we should get ASAP the Rust code for OpenTelemetry and the basic plumbing.
Yeah, but
Sorry,
yeah, but
and
like
also define SLAs, SLOs on code indexing.
yeah, that's like unrated, but like infrastructure why like if we think about like the infra and the like there's already Kibana in place, there's already Grafana in place. We'll hold off on most of that stuff until the mini summit's done. I don't think like we don't have a deployed service, so I don't think it matters, but
I don't think
it
there's
could
anything,
matter.
I don't think there's anything to hold off on because it's going to look the same. Like as long as you're gearing for K8s, then it's fine, right?
Right.
So if we plug into the existing infrastructure for that, then it should be okay.
All right.
Boom, boom, boom.
Yeah, Prometheus metrics, like those need to be defined.
Yeah.
I need you guys to like think through what are the metrics, right?
Yeah,
Yeah, we'll
like
burn and
File
traffic tokens.
parsing, throughput, like what are all the different things that's what I'm saying. It's gonna actually benefit the community edition because we're gonna actually make it a service. And with that comes a lot of like probably gonna be a lot of refactoring, in my opinion, to make it better, right? Make it more maintainable.
Oh, definitely. There's a lot of junk in there. So yeah.
Health checks, like the memory issue needs to be solved. Memory upper bound limits.
upper bound, yeah.
Yeah.
Important stuff before we dive into all of this. We need some kind of configuration management so we can enforce some configuration on knowledge graph. For example, setting upper bound of memory or setting OpenTelemetry collector URL, for example.
Yes,
Like that.
that's all going to be part of the epic that you guys did. You see what I'm saying?
Okay.
That's why I wanted it to be a separate epic, and then we can maybe look at what needs to be done for the querying side, right? Which is I think Jan's got pretty good work on that so far. And then the graph node management aspect, indexing, re-indexing. So like if anything, if you guys want to take the lead, like Mike, you can take the lead on re-indexing and all like just create an epic for re-indexing. Like that needs to be figured out regardless of the SDLC architecture, right?
Exactly. Yeah. No.
And
the logic there, yeah, it's gonna
you
be
can
the same
assume
either way.
like the indexing tasks are going to be the same no matter if it's coming from Siphon or if it's coming from Postgres, right?
Correct. Yes. Yeah.
Right. So that's what I'm saying. Like a lot of the stuff that we can be doing in the next 3 weeks are not showstoppers in the overall architecture planning if we choose to use Neo4j, if we choose to use
I agree. Because the way
yeah.
it's going to be designed is it's going to follow the same fundamental principles. We're going to have the executor phase, you
Yeah.
know, the writing phase, the copy phase. Yeah.
Yeah, all those things need to be metrics too, in my opinion.
Mhm.
So we need a metric for how long the parsing phase took, how long did the analysis phase take, what is the memory consumption in each of those phases. We should be able to see that in the Grafana thing, right? Like all those different things we should be able to see. Yeah. What do you guys think?
That sounds right.
Yeah.
Yeah. And as I do, oh, sorry, go ahead.
I just wanted to boast that I have a ton of like Prometheus and OpenTelemetry experience. So
Perfect.
That's what I'm saying. Like,
hopefully,
that's what I was-
hopefully it's gonna be helpful.
Yeah, so that's what I'm saying. Like, I want you guys to take it, run with it, take the lead on it. I can focus on the proposal for SDLC, working with data engineering. We're all going to be working with data engineering, but I can focus on that and the Get Elite client and the which we need to get Elite client anyways, right? And the querying aspect with Dimitri.
Yeah.
And Omar has the indexing aspect. So he's going to handle all the plumbing into indexing and maybe even the plumbing of hooking up the indexing to the indexing endpoint, but he's going to set up the indexing endpoints. So Omar has the indexing endpoints, and he'll be probably working with you, Mike.
Yep. And I'll just,
Re-indexing.
yep. And I'll handle the core of the indexer, all that stuff. Yeah.
And then Bogdan, Jean-Gabriel have observability and resiliency. Let's call it that. I like that. Observability and resiliency. What do you guys, I like that. What do you think? Okay.
That works.
Sounds
That works.
We'll create an epic for that. And then we'll also need an epic for Rust to get a lead client. And we have already the epics for querying and graph node management. So that should keep us plenty busy for 18.5. And we'll hopefully have a picture because we'll be talking in async on designing the proposal with data engineering for SDLC indexing. That's
Yeah.
what I was thinking. Does that sound good, guys?
I think that makes sense because there's
Yep.
no really new features or anything crazy. It's honestly just a lot of cleanup.
Clean up and just making it better. And a lot of the telemetry work and all that stuff actually compounds because then once we pull in the data for SDLC stuff, we already got all the plumbing there. You just add the events, right?
Yeah, that's right.
And actually, Mike, you should add to maybe re-indexing as a subtask or something, thinking about whether we should just go to string-based IDs, right?
Yeah. Mm-hmm. Yeah.
That would set us up for again, we have to pick whether we're using Neo4j or not. I don't know. Those are questions we need to figure out. But the database design will definitely help us. I don't know.
Absolutely. And something else I'm going to do too is need to finish that the macro work that I was doing. Ideally, pretty much 95% of our database, like, you know, ingestion code is automatically generated like at compile time. So
Okay.
so this will just play well into that and end-to-end testing as well. So make it all come from the same place, just right from the schemas. So if we do a change like that, it'll be very easy for us to measure. And I just need to do that kind of change anyways, because there's parts of the indexer that are still pretty nasty. So
Yeah.
a lot of duplicated code, a lot of crazy stuff. So yeah, I'll just as I do a reindexing, that is definitely the like deepest part of the indexer that touches pretty much every part. So I'll just kind of, you know, in a lockstep, I'll go through all the parts of the indexer and see what I can clean up. So
Okay. That sounds good.
cool.
What do you guys think?
Yep.
Good with that.
I'm
Makes sense.
good with that.
In terms of availability, I will be gone October 9 to 12 for
Okay.
John's wedding. So
Yeah, I'm excited for him.
oh yeah. It's gonna be a good time, man. I'll make sure to send you guys pics. So
Yeah,
But,
on my side, I'll be out like a full week on from the 13th to the 17th.
I'm also planning to take some since the end of October, somewhere like from 23rd to like 30th maybe, something like that. But if I like take a lot of time off, I'm not gonna be like completely deaf at that moment. So gonna be helpful.
No, it'd be fine. Take the time you guys need. All right, sweet. Let me stop the recording.